Hello, hello, hello. My name is Chris Reese, and I'm one of the subject matter experts here at Award Solutions. And I want to spend just a few minutes and talk about an introduction to IMS. The reason I've chosen this topic today is because IMS has become and will become a more important role within LTE. Here's the picture that I kind of want you to have in mind as you think about IMS. We have the evolved packet core, or EPC, and that is our core network that we have for LTE. And it's going to be, as the name implies, packet-based. We're going to have the evolved UMTS Terrestrial Radio Access Network, or EUTRAN. And that's going to be the radio access network that we have within LTE, and it will be composed of those E-node Bs. And these two networks will connect to each other via IP. Now, the EPC network is designed to just support all packet networks, all packet services. It is not designed with a circuit aspect to it. So one of the ways that people are looking at providing the basic voice component is to use voice over IP. And one of the ways that they're looking at doing that is with the IP multimedia subsystem. And it will be one of the networks that the EPC network will connect to. Now, I don't want to limit the EPC to just connecting to IMS. I want you to think about IMS as being really a service network. And we sometimes get a bit hung up and call it a voice network with an emphasis just on voice, but really it's services in general. But that doesn't preclude us connecting to just the internet for basic internet services. Now, what I want to do today is I want to spend just a couple of minutes and I want to open up the IMS network and talk a little bit about the components that are there. We can take the IMS network and we can really divide it into 5 basic components. The first component we have is a call session control function. And this is going to do all of our setup processing. You can think of it in having a very similar type of role that an MSC plays in a circuit switched voice call. It's the thing that's going to connect to our database to see if the subscriber is allowed to request that type of service. Depending on what the specific service is, it may handle the service on its own or it may go to another network, which we'll talk about here in a second. One of the components that this node needs to communicate with is a home subscriber server, or an HSS. Now, this HSS is going to be very similar to an HLR that we had in a 3G network. This is going to be a subscriber database. As a matter of fact, this may be the same node that we had in the EPC. If you go and you look at the evolved packet core architecture, there's an HSS, and that could be the same node or it could be a separate node depending on how a vendor or an operator wanted to set that up. Now, if the type of services that I'm providing at this point are only IP-based, if they're only between two mobiles that are IP-based mobiles, or between the mobile and the internet, for example, then these are the 2 key nodes that we need to worry about. But if I start to think about things like VoIP, I'm thinking about making a phone call and making a phone call to the PSTN. And so I would need to have a node that lets me convert from IP speak, from voice over IP, into what the plain old telephone system speaks. And those are going to be 2 nodes. One's called a media gateway control function, and the other is called a media gateway. And those two nodes are going to connect to our PSTN. Now, what happens if we're wanting to deal with something that's not just plain old voice, or even a plain old point-to-point video conference, or anything like that? What if we have something that's a little bit more sophisticated that we're trying to do? Well, there is another node, another network, I should say, of application servers. And those application servers are going to provide the more advanced network services. And so those could be things like media processing, digit collection, gaming servers, DRM servers, any type of server that an operator wants to provide. These servers don't necessarily even need to be owned by the operator. They could be owned by a third party. And there are some secure links that are defined within the IMS architecture to support communicating to that external network. One other node that I want to make sure that we discuss is really going to be the glue between the IMS network and the LTE network, and that is a node called a PCRF. Now, PCRF stands for Policy Charging Rule Function, and that is going to be the node that communicates to the P gateway, the PDN gateway that we have in the EPC, for the sake of communicating what a subscriber has been allowed to do. So, for example, if I am doing a VoIP call, then this will tell the P gateway that I'm allowed to have a LTE bearer, a data session setup for a VoIP call. If I'm doing video or whatever, then the PCRF is communicating what those rules are. All of these nodes communicate to each other via an IP network. And so all of these are IP-based. And most of the signaling that goes through this network is going to be SIP-based signaling. Now, we don't have time today to talk about SIP or even how this network will be laid out, but I want you to at least be aware that SIP is going to be a key component to IMS, which means it's secondarily going to become a key component to LTE. So when we think about the IMS network, what I want you to think about are all of these nodes here. This is really our IMS network. I hope this introduction has been useful to you. I hope it's been interesting. I look forward to any feedback that anyone has about any of these videos. If there's any type of video you would like to see put together on a specific topic, please feel free to let me know. But until next time, my name's Chris Reese. This is LTE University, and I hope you have a good day.